My name is Brooke Marshall Garcia. I'm a principal member of technical staff in the Renewable Energy and Distributed Systems Integration Program at Sandia National Laboratories. I have a background in civil engineering as well as energy policy and climate. Microgrid training for stakeholders is a program that I co-developed and have facilitated for island communities in the past. This training is available through the Community Technical Assistance offered by the Energy Transitions Initiative Partnership Project. A little bit about the training. The training leverages systematic, step-by-step frameworks developed by Department of Energy laboratories to help communities develop a conceptual microgrid design specific to their threats, their needs, and their investment options. The course aids in defining resilience and resilience goals, and in conceptualizing a custom microgrid that achieves those goals. The course walks attendees through an overview of the electric system and the concept of resilience. We bring together necessary stakeholders and evaluate site-specific information. We evaluate together how to use a microgrid to improve resilience. We work through the framework in order to quantify the challenges and the opportunities. We often evaluate and integrate into the design things like local policy and regulatory constraints. We look at renewable energy or emission reduction goals. We look at site-specific threats. We look at critical loads and critical infrastructure. And we characterize the system needed to achieve the community's goals. We then use computational tools and methods to develop a proposed microgrid solution.
Hello, my name is Robert Broderick. I am a principal member of technical staff at Sandia. Been at Sandia for the last 9 years. My background is in power system engineering. I lead a team focused on the development of advanced methods and analysis techniques to study the effects of high levels of renewable deployment and to look at innovative solutions to enhancing the resiliency of the electric distribution system using distributed energy resources. As Brooke just mentioned, the output of the training is a conceptual microgrid design. I'm going to discuss how we can provide you technical assistance and analytical tools to flesh out that microgrid design. The primary tool that I'm going to speak about today is the Microgrid Design Toolkit. It is a decision support software for microgrid designers. It is used in the early stages of the design process. It uses powerful search algorithms to identify and characterize alternative microgrid design decisions in terms of user-defined objectives, such as cost, performance, and reliability. Using MDT, a designer can search effectively through a large design space for efficient alternatives. They can investigate the simultaneous impacts of several different design decisions, such as renewable generation versus fossil fuel generation. And then they can also gain a quantitative understanding of the relationships between these design objectives and the trade-offs associated with the alternative technology design decisions. So there are 4 stages of the MDT process that I'd like to discuss with you quickly. So the MDT process starts with defining a baseline system. Then the MDT goes into a process of specifying your design options. This is where you're looking at your different technology choices, how you're going to connect them together. The next stage, the 3rd stage, is to define your design objectives, such as energy availability, how much fuel you want to use, what level of renewables you're targeting. It then runs through an optimization and gives you a whole set of results to look at and to investigate. One of the primary outputs of the MDT tool is something we call a Pareto frontier. The Pareto frontier is a way to limit the vast number of design options that you have and look at a optimized frontier of options. And so it basically gives you an example we will show you here as a cost versus performance, and allows you to look at, okay, what are my trade-offs of using various amounts of PV in this microgrid. So next I'd like to talk about how MDT and underlying technologies have been used in several projects throughout the United States, but specifically a project in Puerto Rico with the Puerto Rico Industrial Development Company, where we looked at a variety of microgrid designs for 5 of their pharmaceutical sites on the island of Puerto Rico, and also the fact that these tools have been used extensively with the US military for years for remote microgrids. So the microgrid tool and our experience with many remote microgrid designs will enable you as the stakeholder to look at your remote and islanded community and understand both the state of your energy resilience today, and then also to develop a project to enhance that energy resilience. So in the time I have left, I'd like to give you a specific example that we went through in Puerto Rico after Hurricane Maria hit. This is the PRIDCO project I mentioned earlier, where we looked at 5 different microgrid sites. And I'd like to go through with you the 4 questions that we learned through that process that all stakeholders should really think about before they begin the technical analysis process. The first question is to make a decision on whether your microgrid is going to be a standalone microgrid or grid-connected microgrid. And what I mean by that is, are you planning on running your microgrid 365 days a year on its own power, or are you going to be connected to the grid? That's a very important decision, both for business and operations constraints when doing these types of analysis. Second key question, what is your threshold or guideline for how you're going to look at the trade-off between renewables and cost? So this is a challenging aspect in all the analysis, so it's really important to have a guideline for what you want to do there. The third question is the status of data availability and what you need. Specifically, what are your loads, and do you have a sense of what your footprint will be for the microgrid? And then finally, the last question is a developer-specific consideration. Have you thought about how you're going to interface with your developers, go through a procurement process? Are you going to have a request for information and then a request for proposals? This is important to think through, as multiple parties can help you with your conceptual design, and you need to decide whether you're going to want an A&E firm to bring you a full solution, or whether you want that information to be part of your request for information and request for proposals. Okay, thank you.